Stan Gibilisco here with a little bit of some answers to some questions that a reader posed to me, and they're very good questions, and I think a lot of people wonder about these things. So I'm going to do my best to answer them. I have his message here before me on another computer, so I would like to answer those questions with some schematic diagrams. First of all, he says, I've bought several of your books and enjoy your writing very much. Well, thank you. I do my best. I'd like to ask for clarification on a couple of things. In an electrical circuit, do you always have both a positive and a negative terminal? Or do you sometimes just go from one terminal to ground? Well, I guess the answer is more or less both. Now, I think that you're referring to a DC electrical circuit. For example, a battery. Now here's another thing that maybe some people have a question about. The negative terminal of a battery is that shorter line there, and the positive terminal is this longer line like that. But when you hold a cell, like a AA cell or a D cell or a C cell in your hand, the little button is the positive terminal and the big flat surface on the other side is the negative. So go figure. There is no standardization in this crazy world. But here you have a DC circuit. Well, it's not a circuit yet. It would be, for example, if we put a light bulb in it. Now we have basically a flashlight without a switch, assuming that that light bulb is the right size. Okay, he asks, do you have both a positive and a negative terminal? Yes, you need them both. But you can ground one or the other. You can ground usually in most electrical circuits here in the United States, the negative terminal is grounded. That is the case, for example, in your car or your truck. The battery, the negative terminal almost always goes to ground. But in some countries, they reverse that whole business, and instead of grounding the negative terminal, they ground the positive terminal instead. So you can have either a negative ground or a positive ground. But you always need to ground one or the other if you have a ground at your disposal. Now, but this circuit will, of course, still work without any ground at all. The flashlight, the original flashlight that you hold in your hand, doesn't have any ground. So there's really no way to specify whether it has a positive or a negative ground. If the flashlight is made out of metal and the shell is connected to the negative terminal of the battery, then maybe you could call that, in a sense, a negative ground. But that's what he means, or that's what he's asking, is do you always need a ground? That's his second question. Do you need a ground? Why do you need a ground beyond the industry jargon, and is it just being in cultured standard practice? Well, I think it's probably you need a ground in some applications. For example, in your alternating current home, you need a good ground in order to protect yourself against getting a shock off of some of your appliances. It doesn't really catch electric overflow. It maintains a zero potential so that, for example, you will not get a shock if you happen to touch something and you're standing on a concrete floor. Whereas and it doesn't really catch any overflow. It's there just to keep to prevent any kind of danger to use primarily, and a fire danger as well. Is it a catch-all to compensate for some inherent voltage imprecision in designing the circuit or something like that? Well, no, not really. Now, a direct current ground or an alternating current electrical ground is one thing, but a radio frequency ground, for example, for an antenna, is a whole different subject, and I don't think there's really time or room to go into that here. But I guess I would say you need a ground for safety reasons if you have a voltage of more than just maybe 12 volts or so. Now he asks about conventional current and electron current, and why can't we just dispense with electrical or with conventional current and go with electron current? Remember, in a battery circuit or a DC circuit, conventional current flows from plus to minus like that. It doesn't really flow though, because it doesn't consist of any objects. It consists only of a change of electrical charge from one place to another. The actual charge carriers are electrons, and they are negatively charged. So the electron current flows from minus to plus. Yes, why can't we just dispense with this conventional current and deal in actual current already? Well, I don't know what you would call actual current, but electrons, even in a DC circuit, they don't exactly flow. They move, they jump from atom to atom. Why has nobody put their foot down on this nonsense already? Well, I'm sure that a lot of people have, but nobody listens to them. It's sort of like, the metric system, the meter kilogram second system versus the English foot pound second system. Well, when you think of the English units, they're just all over the place. They're ridiculous. A foot is 12 inches, a pound is 16 ounces, or a pint is 16 fluid ounces. A mile is 5,280 feet. A yard is 3 feet. They're all just all over the place. It doesn't make any sense. It doesn't have any rhyme or reason to it, but people tried to put their foot down about it and impose the metric system on everyone, and they just wouldn't do it. People are stubborn. People want to stick with the old ways, and sometimes, I don't know, people are just boneheaded sometimes. That's all I can tell you, man. That's all I can tell you. It confuses me because, you're talking about stuff like Ampere's law. Remember, you talk about a coil of wire, or say a wire loop. You have a plus charge and a minus charge and a wire loop. Well, which way does the magnetic field go? It depends on whether you're talking about conventional current or electron current, and it's just a mess. It's just a mess. Finally, I don't see why the terminology drawing current is used. Well, let's draw our venerable old battery circuit again. Sorry about the sloppy drawing. I'm still skittish about putting my hand down on this screen, even though, let me try this again. Let me just practice here. I'm going to practice in front of you. How do you like that? But if you really want to know the answers to these questions, you'll bear with me. Here's the battery once again. Remember the plus terminal here, the minus terminal here. There's a resistor. And that resistor has a certain resistance R. You have a certain voltage in the battery E, and a certain current flowing I. Well, now we'll talk about electron current, not conventional current. Anyway, remember Ohm's law, of course. I, the current in amperes, equals the voltage in volts divided by the resistance in ohms. Well, this resistor dissipates current in the form of heat. It dissipates power in the form of heat. As current flows through that resistor, the resistor dissipates power that depends on the value of the resistance and the value of the voltage. Now, when you talk about this thing drawing current, we're talking about semantics here. We're talking about what does the word draw actually mean. And I guess the term comes from, well, actually, a technician when I worked in Miami Beach is where I first heard that term, and I thought it sounded sort of cool. It's a resistor draws current the way that when you turn the faucet on in your tap, you draw water from the tap. It's just a term. It's not really a big deal in my opinion, and this is just an issue of semantics, and I don't think it's very important as long as people know what it means. You might say that instead of to draw current, the resistor will demand current. But then again, you could say, well, geez, what's the resistor doing? Sitting there making demands. I mean, it's not even alive. How can it make demands? So the answer to that question, I think, is it is inane. I mean, but everything's inane these days if you think about it enough. It's just a term. That's not a real big deal to me. The conventional current deal is a big deal, and I wish I could put my foot down, but if I did, I might as well try and stop the tides from coming in and out. It's just not going to work, man. It's just not going to happen. It's just going to be inane, and there ain't a doggone thing we can do about it. Now, and so I'm not going to lose any sleep over it. Stan Gibalisco, ham radio operator W1GV Whiskey 1, good vibrations. Signing off until next time. 73, which means best regards, and so long.